is the last day that you'll be able to use the Zoom link that you used today. Zoom only gives me 7 weeks. That's all I can use it for, and then it kind of dies. So be on the lookout for an email giving you the new link for the rest of the quarter. I'll put it in Canvas as well, and I'll send you out an email saying this is our new link, and that's what you will use starting next week, right? Starting Monday. A little funny idiosyncrasy of Zoom that it doesn't allow you to like book, 4 years. Maybe that's why they don't, right? They put a limit on how long you can do it for. But little thing, we have got essentially 2 pages of formula here. You probably want to write down most of them, maybe not right now. I think the easiest way to do it is go back sometime when you've got time, watch this video, pause on this page, and then write them down there, right? That'd be the quickest. Could also go online and just do the headings and get them. My goal today, little pen mark, I want to do another one of the half angle guys, because they do seem to be a little bit messy, and I want to make sure that we've got that one. So I'm doing one more of these guys. After that, we're going to look at product to sum and sum to product equations, and I stuck a couple of identities that is useful. These ones are really plug and chug. You're just going to be given some like the cosine of 5x, cosine of 2x, rewrite it as a sum. And so you'll just say A is 2x, B is 4x, and you'll do what it is, right? So they're not hard to do. They're really just skill building, just different things that can happen to trig functions. So this is taking a product, which is 2 things multiplied, and reducing it into the sum of 2 things, or the difference. And this one takes the sum or the difference of some trig and turns it into a product. So one of them goes from products to sums, other goes from sums to products. And
are those all new equations?
They are all these ones here. Yeah, these are all new equations. So don't expect anybody to memorize them. I don't memorize these guys. I memorize them. That's obvious, but none of these. I memorize these because these are useful.
And that does say negative cos b, right? For the cos of negative b equals negative cos b.
Yeah, that's the only one where there's a funny negative. It kind of breaks the pattern, doesn't it? It looks like there's a nice pattern going on, and then this one has a negative. Yeah, go figure. I mean, there are reasons.
No, in the middle.
In the middle?
In the up, middle of the page.
Yeah.
Yeah.
That there. That's cosine of negative b is just the cosine of b. There is no negative.
It's just oh, okay, cool. Thank you.
I don't know what my C looks kind of funny. It's got a little mark in it, probably. Got a little mark there. Just picking up marks. Okay, let's get this show on the road. Let's do one more of these guys. So we are going to. Can I pick one? That might be easier. It's an idea. Okay. Suppose I tell you that the cosine of x is negative 1/3, and that I tell you that x is let's do x is from 90 degrees to 180 degrees, and I ask you to find the exact value of the cosine of a half x, and let's say just the tan of a half x. So far, so good, right? Now, would you agree that this information here is just another way of telling you that x is in the second quadrant, okay? Great. Now, which quadrant will the angle of half x be in?
Quadrant 1.
Yeah, so 45 to 90, right? It'll be in quadrant 1. And the reason we need to know this is to make sure we get the pluses and minuses sorted out. So I'll return to Put a little line here. I'll return to this piece of information because this is where we're going to start, which is that guy. And I'm going to build my right angle triangle, which is a technique we use for lots of situations. And I'll name the sides. This side is the opposite. This one is the adjacent. And this one is the hypotenuse. And in a cosine, according to SOHCAHTOA, the cosine is the adjacent of the hypotenuse. So that's going to be a 1 and a 3. And if you use Pythagoras, anybody want to have a shot at it, do it in their head, what would be the third missing side, the opposite in this right angle triangle? Square root of 8. Yeah, square root of 8. Right, so I want the cosine of a half x. Well, it's this guy here, right? And so I need to know, is it a plus or a minus? So I look at where a half x is, right? Because I'm finding the cosine of a half x. And a half x is in the first quadrant. So does it not make this positive? Right, and that's it. That's pretty much all that does. It tells me whether I should use a plus or a minus. And then I do a square root. And the formula is going to be 1 take away the cosine of x over 2. So that's going to be 1 take away. And I don't really need to worry about the value of the cosine x. In this case, we already know what it is. And so
Isn't the cosine one plus?
this guy here?
It's 1
Yeah.
plus cosine.
1 plus cosine. The sine
Oh,
is.
did I write there? I did. Well caught. Thank you. I just scanned. Yeah. So yeah, it's 1 plus. And oh God in Himmel. That's 4/3 divided by 2. Could actually let the calculator do this. That's a square root of 2/3. Style points. Do you think you can do much with the square root of 2/3? I mean, if I try to, wouldn't it just be the square root of 2 of the square root of 3? Do you think that's much better?
Wouldn't it be 2/3 on the top and then over 2? Not 4/3.
Did you all catch that deliberate mistake? Well, actually, this one's not bad. In fact, this one does tidy up quite nicely. Okay, we are done with the cosine guy. I'm going to try and squeeze the tan guy up here. Run, change paper. And the tangent can use either one of these. I'm going to use the first one. So it's going to be 1 take away the cosine of x all over sine of x. And I'm going to put a little bubble around it. I know what the cosine is. It's this guy. So 1 take away negative gives me a plus. If you look at this right angle triangle, it will allow me to find the sine of x. And won't the sine of x be square root of 8 over 3? So far, so good. Now that I've noticed that this is going to involve a lot more work, and I thought, that's the guy. If you times the top and bottom by 3, special version of 1, you'll get 3 plus 1 over root 8. That gets me 4 over root 8. Are you okay with that? Another way of doing it is add these together and you get 4/3 over root 8 over 3. The 3's cancel and you get 4 over root 8. That's just a different approach. Right, can I make this prettier? Style points, 4 over square root of 8. Can you do anything to make this look nice? Yeah. Any suggestions?
It'd be 2 root 8 over 4, or root 8 over, wait.
Right, that's what you meant. Square root of 8 is 2 root 2.
Oh, okay. Yeah.
And that cancels down to that. Can we
And
do anything better to that guy?
root 2 over.
Okay, and that gets me 2 root 2 over 2. And that cancels down, and guess what? You don't really know, do you, what you're going to get unless you have a shot at it, right? And that answer is, unless I screwed up, which I seem to be doing a lot of today, isn't that answer really nice? At least it's nicer than that. When you're doing the tangent of a half angle, you don't care about the plus or minus. There is no rule necessary, because won't the calculation tell you if it's plus or minus when you're finished? And that is the end of that little guy. So let me bring these guys back to haunt us. We're looking at essentially rewriting 2 things multiplied as a sum, or 2 things added as a product. So the questions are pretty varied. So some have numbers and some have expressions. So I think the first one I'm going to do is number 9. And it says, find the value of . They really should say find the exact value of, but that's fine. The sine of 90 degrees, take away the sine of 30 degrees. Now, as I scan through my sets of formulas, there's a sine, take away a sine going on. And so I'm looking at this one, number 3. Do you see it? A sine, take away a sine. So this is like my A, right? And this is like my B. So I'm going to take these 2 and rewrite it as 2 times the cosine of A plus B over 2 times the sine of A minus B over 2. And A is 90 and B is 30. So let's see what we get. 2 times the cosine of 90 plus 30 over 2 times the sine of 90 take away 30 over 2. And so what's that, 120? That becomes half of 120 is 60 degrees. And this guy is 30 degrees. And since they want the value of it, I'll use my unit circle, which I found. Cosine is 60. There's 60. The cosine is a half. Sine of 30. There's a 30. The sine of 30 is a half. And all of that ends up being a half. Does that seem reasonable? At least, you know, what we did. 2 guys subtracted, find the relevant formula, figure out who the A and B's are, get the numbers, use your unit circle, finish it off. Next one is question 10. And it says, write the product. So write this product as a sum. And let's see what the product is. It's the sine of 5x times the sine of 7x. So we have a whole load of equations that could be used, but only one of them is the right one to use. So I'm going to call this guy 1, 2, 3, 4. Call this guy 5. Call that 6, 7, 8, 9, and 10, right? So they all have a number. Just random numbers, right? Which one of those 10 formula is the one that you're going to use to turn this product into two things added? Scan through your list.
Number 2.
Number 2.
Agreed. 2 people on 2. Let's see if it's got the feature. A sine and a sine. That's the only one that works, right? Now, in this world, A is going to be 5x and B is going to be 7x. So our formula is 1/2 a bracket. The cosine of A take away B, subtract the cosine of A at B. Oh, shooting space. A add B. There we go. I didn't swear. I said shooting space, didn't I? So it should be the cosine of 5x take away 7x, subtract the cosine of 5x add 7x. That's what my next line should have looked like. So that's going to be 1/2 the cosine of negative 2x, subtract the cosine of 12x, and everything's looking good, right? But we have a kind of style point rule with trig. Here's a little miniature style point rule. We don't like cosines or sines or tans to have negatives inside them. So I don't like the cosine of negative 2x, right? We don't like that. So I'm going to use number 6, which says the cosine of a negative angle is just the same thing as the cosine of its positive. And the result then is that this guy is the cosine of 2x, take away the cosine of 12x. Are you comfortable with that little tweak at the end? Cosines of negatives or sines of negatives we don't like, right? So we use this, one of these two here to fix it. Any questions so far? I just plug and chug, right? Find the right formula. No particular explanation of why you would want to, but they're letting us do it, so that's always cool. How about question 12 then?
I do have a question.
Yes.
How come there's no more formulas? So let's say like for the sum to product formulas, why is there no like a sine A plus a cosine B?
There is such a formula, but we don't do it.
Okay. So it's always sine or cosine.
Yeah.
Okay.
But if you're interested, go and look out. If you want to do a combination of sines and cosines, and it doesn't matter which one is first and which one is second, the formula is k cos x minus alpha. And k is the square root of the coefficient of x and the coefficient of the other guy squared and added. And alpha is the angle that you get when you do the tan of them, which is probably explains why we don't do that one.
Right. I have a question.
Yes, Kate.
For negative tangents, like like tangent negative a, what is that also just not a negative, or is it like the sign?
Well, firstly, you wouldn't worry about it because they don't exist for these, but it's a good thing to tell you. You've got a choice. Do you think it's negative tan A, or do you think it's just tan A? Is it more like this guy, or is it more like that guy? Which do you think it is?
Not sure.
More like the cosine.
It is going to be negative, And it behaves the same way for the same reason. And the reason these plus and minuses happen is to do with all sine tan cos. If you're in the first quadrant and you're in the fourth quadrant, right? In the fourth quadrant, aren't you a negative angle? Right? And a cosine in the fourth quadrant is the same answer, it's still positive. So that's why that one works. But if you look at angles that are in the fourth quadrant, which these two guys are, they end up being negative things. So if you're interested, where does this come from? It comes from all sine tan cos. So that's that one. Technically, since we're doing this, wouldn't the cosecant of negative A be negative the cosecant of A? Wouldn't the secant of negative B be just the secant of B? And the cotangent of negative A would be negative the cotangent of A. So you could actually expand it, but I'm not sure I would ever want to use those other ones. So question 12 has the sine of 9x take away the sine of 3x. I think you're frozen.
I think it happened. They hit a wire. Oh, he's gone.
Oh no.
Well, that's not good.
I'll teach it, you guys.
No, we jinxed it. We'll wait.
Who's gonna be the teacher? Step up.
You should do it, Katie.
Let's see what we would use. I screenshotted them. I did not write all of them down. What did he say it was? Did anyone write it down?
12. He's going over 12 next.
Did you write down what the question was? Or did he say?
Yeah, I think it was the sine of 9x minus the sine of 3x.
Okay. Let's see. So what do
That
you
looks
do,
about
seven?
right. I'm looking at the problem right now, and mine's a 2 and 7 instead of a 3 and 9.
Mine's
You wanna-
3 and 4.
Do you want to do a vote on which numbers to use, or do you want to just use the numbers that he said?
You can just use the number he said.
All right, so it would be it would be 2 cosine, big parenthesis, right? Of
A plus B
a
over
plus
2.
b over 2.
And then cosine A minus B over 2.
What's the numbers we're using?
9x and 3x. Sine of 9x minus sine of 3x. Okay. A minus B over 2. It's 12x over 2. Do you think he's coming back?
I don't know. We'll find out.
Yeah, I mean, if it's related to his power, it might be like, yeah.
Did we all get 2 cosine of 6x and then times the sine of 3x?
I think 2 cosine 12x over 2.
Yeah. Oh, sorry.
You
I
add,
meant
you add
no, at
12x
the
over
very
2.
end. 6x sine 3x.
Oh, sorry. My bad.
Are you good?
6x over 2. And let's see. Okay, and then 2 cosine. Yeah. Is that all? You can simplify it, or do you do anything after that?
I feel like that's it. For the product as a sum was the last, I was looking down, but was the final answer a half of cosine 2x minus cosine 12x? Or do you do some
Yeah,
of
that's what I got.
that? Okay, so I'm assuming that's all you do then.
Does
Yeah.
anybody have the
Easy
last
peasy.
product to sum formula?
Yeah, I do. I have
It's cosine
Sine-
A
a minus
times sine B is 1/2 of sine A plus B minus sine A minus B.
Okay, thank you.
And then what did you guys get for the answer for problem?
2 cosine 6x times sine 3x.
That's what I got.
Cool, cool.
I also got that. So
Do you want to do the last 3 problems on the homework?
How many have we done so far?
So far in class, we've been up until number 10 on 7.3. And I
We
think
just
is there-
did 12, right?
yeah.
All right.
So the last, I don't know how many there are actually. Hold on.
Have we done
I think it
11
might
yet?
be like
Oh,
oh
yay.
Is he back?
Yeah.
said it
Oh,
was the
fun.
host.
Yeah.
I think there was like 4 of those questions, but I
Is
kind
there
of already
4?
finished it.
I think
Oh,
those
did
ones
you?
are pretty easy.
Yeah,
so
I
you can
did
pick-
it while we were in class.
Oh, okay. There you go.
Is there any harder ones on there or no?
Not really.
I near the
Hey,
end they
back.
get pretty easy.
Are they all the same? Okay.
Yeah, they're pretty good.
Yeah.
Okay. No like story problems or anything.
No,
No, not that I see.
there's nothing crazy
The
at the
story
end.
problems have been kind of hard this week, though. Have they been for anybody else?
So which ones?
They haven't
I
been
got a couple of
hard for
story
me as
points.
much as trying to actually figure out what to do.
Yeah, mine's mostly
Yeah, that's
been,
what I've been having too.
Can you hear me now, guys?
Yes.
Yeah.
yes,
Yes.
Yes, I can.
Okay. I
We
was
didn't hear.
ranting on about stuff. So now we're back to our storyline. I'm looking for a sign, takeaway a sign, which is number 9. And I'm going to call this guy A and this guy B. So your answer will be 2 times the cosine of 9 add 3 divided by 2, followed by the sine of 9 take away 3 divided by 2. And this ends up being 2 times the cosine of 6x, followed by the sine of 3x. Does that look good, guys?
Yes, indeed.
Right. Now,
We did it right.
you did it right. Yeah. Now, let me show you something. Isn't the sine of 2x the same thing as the sine of x add x? Agreed? And so if I did a sine plus a sine, wouldn't it be number 7 I should be using? And won't A and B both be x? So let's see what that looks like. Twice the sine of A plus B over 2 times the cosine of A take away B over 2. And that gets me to oh, I'm using the wrong one. My apologies. It's okay. I won't do that. We are pretty much finished with those questions. Just give me a few moments to get back into all the other stuff that crashed when it went weird on us. Anyway, we're pretty much finished. I was going to try and prove to you what the sine of 2x is, but it never came out. Let's do a login. Let's see what else. I think I've covered everything. I just want to make sure that I have. on. You know, I'm going to get all this loaded up and the guys are going to put on some drill and do a spike in the voltage and knock me out of the internet again. Okay, keep going, keep going. Here we are. Done, done, done. Covered. Yep, covered. Yep. That is it. We are finished. And then we'll call it a day. Have a nice early day. So make sure that you get your homework complete by Sunday. You know it's up to and including this one. Your online test is there. And the grades that you got for online homework 6 are now visible. So you should be able to get in and see what your grade was. I'm going to hang about for any people who might have